Hello everyone. Today we are going to talk about stacks, part of data structures using C++ course. A stack is a last in first out data structure where the last item added to the stack is the first item to be removed. The basic operations performed on a stack include push to add an item to the top of the stack, pop to remove the item from the top of the stack, and peek to retrieve the item from the top of the stack without removing it. For example, consider a stack of plates. Imagine you have a stack of plates and you want to add a new plate to the top of the stack. You can do this by placing the new plate on top of the existing stack, just like a push operation. If you want to remove a plate, you would take the plate from the top of the stack, just like a pop operation. If you want to see the plate at the top of the stack without removing it, you would simply look at the top plate, just like a peek operation. In computer science, a stack can be implemented as an array or a linked list, and its size can be dynamic or fixed. The stack data structure is widely used in various algorithms and data structures, such as backtracking, memory management, expression evaluation, and others. In C++, stacks can be implemented using standard template library, that is STL, or by manually implementing a stack data structure. Here is an example of using the STL stack class. In this example, the STL stack class, which is part of the stack header file, the stack class provides the basic stack operations such as push, pop, and top. To use the stack class, we include the stack header file and create an instance of this stack class using std stack int syntax. In this example, the stack is created and 3 integers are pushed onto the stack using the push method. The top method is then used to retrieve the value at the top of the stack, and the pop method is used to remove the top element from the stack. Manually implementing a stack, you can also implement a stack data structure manually by using an array or a linked list. To implement a stack, you need to define the structure of a stack node, which will hold the data and a pointer to the next node. The stack can then be implemented as a linked list, where the top of the stack is always pointed to by a head pointer. Here is an example of manually implementing a stack using a linked list. The second example shows how to manually implement a stack using linked list. In this example, we define a structure stack node that holds the data and a pointer. The stack is then implemented as a linked list where the top of the stack is always pointed to by a head pointer. In this example, a class stack is defined that implements the basic stack operations such as push, pop, and top. The push method creates a new node and adds it to the top of the stack, updating the head pointer to point to the new node. The pop method removes the top node from the stack and returns its value. The top method returns the value at the top of the stack. The main function creates an instance of the stack class and demonstrates the usage of the stack by pushing three integers onto the stack, printing the value at the top of the stack, and removing the top element from the stack. Hope this was helpful. Thank you for watching.